everyone. In case you're joining us back from our streams in the morning, you all know I've been streaming since the past two streams, and you all are welcome back. If you all are joining us from the first time, how's it going? I would love to know how's your day going. It's a Saturday, and we've been streaming continuously, and I can see already a couple of morning hackers back. Welcome back, Anand. Hi, you all. And let me quickly get rid of the banners and continue. Hi there. I think you're joining us for the first time since morning. I don't remember seeing your comments before. Yash is back. Welcome back, Yash. Gulapali is back, which is also amazing. I'm so glad you all are joining us back for the third stream today. And yeah, I am very excited to kind of wrap the stream up already because I've had such a great time interacting with you hackers. I can actually, I'm going to remember a lot of y'all, and this is great because I'm looking forward to seeing y'all at the FPHs. You will if you're acquainted with basic Python, I think you'll do fine because that's the amount of Python I know, and we'll be making the game together. It's a glitch based workshop, so you don't have to write a lot of code. You'll just be kind of adding chunks of code and understanding that code, which is what is more important. So no, you do not have any prerequisites basically at this point. If you know a tad bit of Python, if you don't know Python at all, again, not a big deal. We already have Python 1, 2, 3 workshops done earlier this week, so you all can just go catch up and then come back to the stream later. Today you all can just hang around and try and add the chunks of code that I do, and if you don't understand it, you all I'm there on live stream for the same reason. Alright, so a quick introduction. I realized I haven't been doing my introduction for the past two streams. So, in case you all are joining us for the first time, I'm Ritvik. I'm a coach at MLH, and this is Global Hack Week. A little too late for me to be explaining what's Global Hack Week, but it's a celebration of hacking where us coaches, develop content and kind of present it for you all. It's beginner-friendly content so that you all can catch up no matter what point you are in your tech careers. And yeah, feel free to reach out to me on Twitter or Discord or any other social media platform. I'm pretty active in the sense of reacting to different posts. I'm not a huge poster myself, but you can catch me on any of the platforms. Alright, so I think we're ready to dive in. I would have liked to wait for a couple of more viewers to join in, but we'll just help them catch up when they do. Alright, so let me quickly start by sharing my screen. There we go. Present a view. And let's go back to the screen. Alright, and I'm gonna make this full screen so that it's that bit better looking. Alright, awesome. Is that a joke I'm supposed to understand, Yash? Because I'm not great with such jokes. Alright, so let's get started. This is all what we're going to be doing today. So we already covered what's MLH welcome Localhost, which is basically us and our partners creating some great content in collaboration specifically for you hackers. It is beginner friendly. It is supposed to be helping you no matter at what point you join in. All right, so you'll definitely learn something new. If not Python, maybe a new line of Python that you did not know existed, glitch if you didn't know it's a glitch, or just the community interaction that is very rewarding at any given point. So if you're here, you're going to definitely take away something. And I love the vibe I'm getting out of the chat, because you all already know each other. Now you have a good rapport with me as well, because I know you've been attending my stream since morning. And thank you, Rishabh. I was about to tell the same to you. Welcome back to the stream. And yeah, thank you, Anand, for clarifying this. And yes, thank you. I thought that was a joke and it wasn't, and I'm glad, because it's very pure, because I almost never get such jokes. Alright, so we're gonna look into game programming. How is game programming any different from the normal programming? Why you want to, just how do you really think when it comes to game programming? Then we'll look into building rock paper scissors. Then we'll also build our own AI based opponent. Then we have some review and quiz, and then there are some steps which can make the entire experience more challenging for you all as hackers. Alright, so I'm going to quickly start going through the slides. The first almost I think 10-15 slides is just content for us to kind of bask in. So, you just understand what's going on, listen to me, blabber a little. I am counting on you all to keep it a tad bit more engaging in the chat, so that way I can blabber more. But yeah, every step we'll be doing it together. So if you get stuck anywhere, let me know. Alright? And let me see if this works better. Yep, it does. Alright, so let's get started. Okay, this is a fun icebreaker. Let's start by answering this. I'm looking at the chat and I want to know what's your favorite game and what makes the game that you play so much fun. No, you all don't play games? Is that what you're telling me? Chess. Yes, I know you will listen to chess because he mentioned about making chess in Definity as well. Well, I think you will. This is a much better place to start because we'll be writing game logic today anyway. So, 3D. Is 3D supposed to be the name of the game or is it the type of game that you like? Chess. Wow, we have a lot of chess lovers here, which is great. So, Yash, when you say 3D, is it the type of games that is all 3D games, or is 3D supposed to be a game that I'm not aware of? Okay, while Yash answers that, nice. I like good visuals too. I'm actually very bad when it comes to games, like proper video games. I have terrible reflexes, but yeah, I enjoy those bubble shooter games, like the one where you're supposed to kind of strategically shoot bubbles. I think that's the only game I've actually ever been a little bit addicted to. And the only other game I was addicted to was Farmville, and I'm not proud of that. Has anyone of you played Farmville? Oh yeah, Mario used to be nice, but I never got addicted to it. I think it was okay. Like I played it when we had this really huge setup, right? So I was really lazy in setting up the entire Nintendo thing, so I never got addicted to Mario. But yeah, see, I tried to play PUBG, but I never really understood how to play it. Like I was never really good again with the reflexes and stuff. So Farmville stand here. Yeah, in hindsight, when I tell people I loved Farmville and then they ask what happened in Farmville, and I tell them, well, I grew vegetables and sold them. Seems a little weird, but yeah, I absolutely love Farmville. I think I've done more networking in Farmville than I did anywhere else. Ooh, retro games. I have heard a lot about retro games. I've never gotten around to playing any though. Which one do you suggest I start with if I wanted to try it out? Nice, nice. Mario fans here. Hmm. Gulapli, I would be happy to get suggestions on what retro games to start with. Alright, so yeah, games are a great way to do a lot of things, right? Is that supposed to be a suggestion for me, or is that the name of the game, Voldemort? At this point, I might as well call you Tom Riddle. Nice, nice. The other day we were supposed to run a mini event with Among Us, but I had only 2 or 3 hackers turn up, so we just decided to play Scribble. Ooh, fun! You've been using Raspberry Pi to play games. Interesting. I'd like to know more about this later. All right, so great. Games are a great way to do a lot of things, right? Make friends, network. In my case, not a great way. Farmville, not recommended anymore. But yeah, games are a great way to go about a lot of things, and they're also a great way to get into programming. So, what makes games different from a programming point of view? Well, it's the rules, right? The games are fun because there are rules and you need to stay in a certain box and think out of it, right? So, without the rules, you wouldn't know what you were doing, and that's exactly what we're going to do today. Understand how do we code these rules into our code. All right. So, can you list down the rules for the name games that you just suggested? For example, I said bubble shooter, right? So, for bubble shooter, what would be the some basic rules that my code would have to follow? First of all, if the two bubbles of different colors hit each other, nothing should happen. Or if there is a penalty explosion happening, that would happen. If it hits the same bunch of colors, bubbles of the same color, the entire set of bubbles should disappear. The animation could be whatever, exploding, tumbling, but basically those variables of those bubbles should basically disappear. What else? When every time the bubble structure goes, the bubbles should come down, right? So these are some rules for the bubble shooter game I like. That is amazing, Yash. I am so impressed by this. I would love to know more about what you wrote in as a code. But so can you all in the chat go ahead and suggest at least two rules for the games that you suggested, right? So Rishabh, did you mean Minecraft here? I'm assuming you meant Minecraft here. But yeah, so chess, Farmville, Mario, PUBG, uh, what else? What else do you mention? Retro games. Mention two rules. Donkey Kong. That's an interesting name. There we go. So that's one rule that you will is enlisted. So yeah, any one of you, even one rule if you all can put. This is so that because when you're trying to code a game, you need to figure out first the game rules, right, and then comes the player rules, right? What the player can do. That's a exactly. If you win, you lose. The game's over. Exactly. That's one good rule. All right. So that's the second rule. You will pointed out. Great job. You will. Yes, the rules should be simple enough for you to code. What was that game in Friends? Bamboozle? Was that the name? You don't want it to be something like Bamboozle. Imagine the amount of effort it would take for you to code and Bamboozle, right? So, alright. So, that's the whole point, right? To be able to code the rules, you need to be able to code the game, you need rules, right? So, great example, Anand. Same for Yash, right? So these are the rules that I'm talking about, that make the game go forward, right? So for you to be able to code your game, you need to have a set of rules, a well-defined set of rules. So let's take tic-tac-toe for example, right? How if you were to go about playing tic-tac-toe, what would happen? So first there's a grid, right? First there's a grid with 9 spaces. That's the first rule, right? Then let's say it's my turn to play. What do? I put an X in any box, right? That's the next rule. If all the boxes are empty, then I get to put an X in any of the boxes. Or a no, right? It can be a no. But the next turn, whoever's playing has to put an O if I have put an X, or an X if I have put an O. That's one and another rule, right? And whoever's the next person putting it has to make sure, the game has to make sure that they can't put it in the same place I did, right? Or you could put an emoji. If I were coding the game, why not, right? So, or we could make the entire board into a birthday cake, right? This is our game. We can change the rules as per we want, right? So that doesn't sound right, right? This, even though it's your game, you can play around with the rules, but how much do you want to play around with the rules, right? While all of this is fine if you're creating a game from scratch and you want to make it crazy, you want to follow the basic rules. Now, if you mess up the rules as much as they did, right? If you messed up the rules in which you can click a button and it becomes a birthday cake, the user will be very confused as to what to do. So your game, when you're writing the game, you have a very set and clear logic listed, right? So that's what you're using to code your game. All right. I think we've spoken enough about why rules are important, right? Even if the computer suggests otherwise, you know when the game is over, you know who is the winner. It's not as complicated as you having to wait for the, you know, code to calculate who won, right? So that is why rules are important, and luckily our code is all about following rules, right? So when we're coding something as simple as tic-tac-toe, or one of you all has mentioned that stone paper scissors are also simple, you just need to code it, right? You just need to write the logic for it, right? So let's talk about state, right? So what is state? Do you all want to take a guess? I mean, it's there right there in front of on your screen, but what is a state? A state is anything that tells you the status of whether a rule is being followed or not, or at what or how is that rule being followed. For example, in your tic-tac-toe, you know that there are multiple rules, like each player only gets one variable, which is x or 0. They can place turn by turn, and these different rules have different statuses at any given point, and the status is basically your state. So whether or not the x player played last, whether it's 0 players turn, whether x's are in a row, whether the number of x's in a row. So all of these different statuses of the different rules can be qualified as states, right? The state is what makes these video games work. So if you look at the current state games, if you look at the current state of all the rules, you can also make predictions where the game is headed. You can also decide what to do next. These states that are you are calculating as a player is what is enabling you to make your next move, right? So these states combined with the rules is what makes the person or the users play the next move, right? That's does that sound fair? So where did my slides go? All right, there we go. All right, so in tic-tac-toe, right, like any other game, rules apply, and each of these rules have states, and the computer looks at the states and decides whether the move that you're trying to make next qualifies for a move. One, second, whether that move will make you win or not, right? So that's how game programming basically works, right? So now let's talk about how to keep going. Okay, so that's one move, second move, third move, fourth move. How do we keep it going until we decide that the game's over? This is called a game loop, right? A game loop is basically something like a while one, but while no one is winning, right? And that can be a simple state of a row or a column. You can simply check whether in tic-tac-toe, for example, your while loop could be while three of the x's are not in the same row, column, or diagonals, right? Those are the only four things you need to check, right? The rows, the columns, and the diagonals. These three things, if you check, you all can decide whether the game loop has ended or not. What is the another thing you need in the game loop is that when no one wins. And that state is when all the places are filled, but there are no three loops. Make it simpler. We can just first check whether all the grid is filled, and then decide whether the game is over. But what would happen if we did that? What would happen if we did that is, even if someone won, if you didn't check for the columns, diagonals, and rows, your game would continue until all the grid was filled. So game loop is very beautifully defined by Yash here, which is initialization, condition check, updation of state. Great job, Yash. Well, tad bit more complicated, but basically this is what we're doing, right? We are entering a while loop, and until we decide that if either one of them has won or no one has won, we stay in the loop, right? So let's look at tic-tac-toe, tic-tac-toe again, right? So let's just go through these steps. So if we have a tic-tac-toe, our computer would see a board and say, hey, you can put X in any of these spaces. And once you're done, it would play its move again and say, now I'm supposed to put a 0, but I'm also supposed to try to win. So that is another state check that the computer is doing in the game loop. And this process, right, of checking continues until either one of them wins. So one side will win based on the states that are being updated and checked in the game loop, and the computer will tell when this happens. But you don't need the computer to tell. That's the whole point of it being simple, right? So that's basically your game programming. What we were trying to understand here, the importance of this entire chunk of slides was understanding the importance of rules, and understanding what one of you very clearly mentioned and very rightly mentioned is the simplicity in rules, right? The simpler you keep things, the logic is going to be as nice, but the more clarity you have in what's happening in the game will help you write better code and make the game more fun, more fair, and more, you know it's more playable, right? I mean, imagine having to play bamboozle on Python. That would be pretty bad, right? So let's get on to what we are here to do today, which is basically build rock paper scissors. All right. So we'll first go through some rules, maybe see what the pre-code that has been written for us is doing. Then we'll go add some chunks of code ourselves, and then we'll make our own AI-based opponent. So sounds fun to me. Uh, let's see what we have next. Okay, there you go. This is the link that you all need to code. Let me quickly put it in the chat. Give me 1 second. And there you go. So you all just need to go to this link, and I'll share my screen to what it's supposed to look like. It will, when you open this link, it will take you to a glitch page, and in that glitch page there will be an option to remix the code, and that's what you want to do. All right, so this is what the page will look like. This is what will open. You can view the source, you can look it over the code, all just browse it through in this window. And what you want to do is you want it to be your own. You're going to be making changes, so you want to click on remix your own. All right, and yeah, once you reach here, I'm gonna stop here for just 1 second and let you all catch up. I would be really happy to know if you all are following along, and just make sure that you all are up to speed. So let's stop here for 2 minutes, and let's catch up, and until then I'll get my page set up as well. Alright, I see no questions till now. I'm assuming you all are up to speed. Awesome. Thank you, Rishabh, for confirming. If you're stuck anywhere, do let me know. We'll stop and make sure that you have enough time to catch up. Anyone else following along? Anyone else on the same page? My glitch is still setting up. So while it does that, I'm gonna quickly. Right, any questions, folks? Awesome. So after opening the program in Glitch Aditya, make sure you click on Remix. That is the important part. I'm just quickly opening mine as well. It's not remixing in this browser for me, so I'm going to open a new browser and remix it there. it's showing you a readme file where you will after you click on remix, or uh, so after you remix it. Okay, let me quickly get there. Interesting. Okay, I'm sorry, my page is loading and I'm just waiting for it to kind of. There you go. This should answer your question. Alright, so Aditya is helping you out, which is very sweet. Thank you, Aditya. For some reason, it won't load my page. There could be multiple reasons for that, and some of the reasons could be me not having enough RAM, but that's okay. Let me quickly load that up. But anyway, until then, you will while you catch up. Let's move on to the through the slides and see what we're supposed to do next. All right. So this is your code. Once you click on remix it, that's your code. It's basically as good as poking the code, and now you can totally edit it, break it, reuse it, make it your own. All right. Uh, it's okay if you're taking your time to catch up, although I'm very sure you all will catch up in no time at all. But yeah, in case you're stuck, do let us know. We're all happy to help you out regardless of what step you're stuck on. All right, so now you can open the terminal as one which you all mentioned. I think, yeah, Aditya mentioned, and you all can start running the python 3 game.py. I don't think you should have to. I think Glitch lets you use it without, but you can go ahead and make a account. Glitch is a pretty great place to have an account, and it won't harm you for sure. So go for it if you want to. I'm sorry, my page is taking a really long time to load, which is why I am waiting for it to just load. And stop. All right, did you catch up? Right. I'm getting rid of all my older codes because it's for some reason taking forever to load. Interesting. Okay, while I figure out why this is happening, let's move on. Alright, so let's look at the code, right? What is this speed? What is this piece of code doing? Ankit, what is the error that you're getting? You want the check-in link? Let me quickly grab the check-in link for you. Okay, my bad. Sorry, sent the wrong link. Or did I send the right link? No, wrong link indeed. Oh, this is the right link. Please do not check into the other one. This one's the link you want to check into. So, Ankit, what's the error that you're getting? Yeah, so that's not an error. You're not supposed to be able to play it right now anyway. And that's why what we're looking into, why you aren't able to play. Ah, I see where you were stuck. Okay, my bad, indeed. Alright. So why aren't you able to play the game? Yes, you will what you want to write is Python 3 and game.py, and that should ideally run your entire code. So just so that you're sure, what's supposed to happen is this. Alright, so you're gonna do Python 3 game.py and yep. Alright. So why is this happening? So when you look at this piece of code, you'll see what's happening, right? So we're saying player move is equal to ask move. So that's going into the ask move function. Computer move is equal to make move, which is the make move function. All right, we'll look into what's happening in those functions in a bit. All right, and state dot append player move, which is basically the return from your ask move function, and round winner is equal to check winner, which is player move, and computer move is your arguments, which is basically uh, the returns from those functions being passed down as arguments. So let's see why we're doing that. Okay. Is this what's Python? Do you all want to confirm whether or not this is the right definition of Python? Alright. So Python is a programming language. We all know that. We all know that it's used for web development. I see it a lot for web development and data science, especially for artificial intelligence, right? So what's the game loop? Why is it happening? This entire game loop is happening when we're checking while not winner. And how do we decide whether or not someone's a winner? Actually, you think the bite in the snake is right? That's great. I'm glad you all have such a great sense of humor. So you will that's what we'll look into why we're losing, and we'll be writing some chunks of logic as well. But let's look into how do we know first of all that ask move is a function, how do we know that this is a loop, and how do we know that the code inside is the loop code. Well, it's a tad bit of a basic things that we're covering, but it will help later on if it throws an error, right? So how do we know it's a loop? Because it's indented inside a while not winner loop, while not winner uh, chunk of code, right? So what's the key term here? The key term here is loops are pieces of code that run multiple times until they're told to stop. I think we're all aware of this, but in case you want, there we go, there you go, right? So while not winner is a loop because it's gonna keep running this chunk of code until you don't have a winner, right? And as soon as you do, it's gonna exit the code. But while it's checking for not winner, it's how do we know this entire thing is chunk of code inside the loop? Because we see the indentation here. Alright? And when does the loop stop? The loop stops when the conditional no longer is equal to true, right? So our conditional checks that there is no winner, right? That's our basic conditional check. Alright, I see the joke still going. Great. Alright, so let's do a quick recap. We know that we're programming a game using Python. We know that our game is going to run in a loop, and we know that our loop is going to keep running until the conditional is no longer equal to true. All right, and our conditional winner is whether or not there's a sorry. Okay. And our conditional checking for whether or not there's a winner is how do we decide that? Well, we look into the code in a bit. Alright. So one of the rules of rock paper scissors is that each player makes their move and chooses rock paper and scissors. Right? We all know that. So our code is going to tell game to follow those rules, right? So over here you can see there's an ask move and a make move are both functions. How do we know both are functions? Because first there is parenthesis, and secondly we know we're getting a return from that because we're storing it into a variable, right? So functions are blocks of code that tell our code to do specific things. They're reusable pieces of code. In this case we can also call this recursion, right? Because we are, well, this is not recursion, I agree, this is far from recursion. This is just repeatedly calling it until some kind of the condition is true, right? Alright, so functions are blocks of code that we use to that is reusable code that we're using multiple times in our entire game, right? Then we know that player move and computer move are both variables, right? How do we know that? Because they're reusable pieces of data, all right, and we are storing values into it, dynamic values. When I say dynamic, not in the terms of size but in terms of the value itself, right? Because it's a variable. And yeah, so we're going to be storing we can store a lot of different types of values. And remember that Python automatically detects the type of data, and we don't necessarily have to specify what type of data that variable is supposed to hold, all right? There are multiple types of data, like we mentioned. There are integers, strings, floats, and longs. But strings particularly stores words and paragraphs. And you can see there's an example here of us using a variable to store a string. Yes, it is. You will, but we'll cover a little bit of everything so that everyone is up to speed. All right. Now, integers store whole numbers and they can't store decimals. We already know that as well. And you do not need to put your data in quotes when uh, you are using integers. Alright? I know this is not true for you all because you all are already pros at coding in some way or another, but that's okay. It can be tons of information if you're joining Hack Week for the first time. And at this point, if you want to take a quick break, if you have any questions, we can do that. Take a couple of minutes to just, let the information and let what we've learned sink in, and then we can move forward. All right. I see that there are no comments regarding that, so I'm going to wait for a couple of minutes and then move on. Let's do that. Let's go over a couple of more slides. We're not very far from the actual coding part. I know you all are really enthusiastic about having to code. So what we're going to be doing is we're not going to be writing a lot of code as much as we're going to start editing the code. All right. So give me 1 second. My glitch for some reason is totally hung up. So 1, 3, 2. All right. I'm gonna take another minute to try and open this. I'm sorry, give me another minute. And alright, that's okay. I'll use the slides to. Well, it won't be easy for sure, but that's the fun of it, right? And I think Aditya here, since he's tried it, he can already help you. I'm sorry, Abdul, that's the fan that I have. It's a tad bit noisy. Alright, great. So let's move on to what we're going to be doing next. Alright. So alright, let's look at some of the rules that we're doing. So For definition, ask move. So this def is how you know that this is a function. Alright, ask move. Look at the colon, that suggests that this is the code, a chunk of code that's inside the function. So we're saying move is another variable, and we're saying input, and we're saying this statement when we're asking the player to give an input. So what are we asking? What move do you want to play? Type rock, paper, or scissors, right? And then we're asking the move, and we're giving the option to type in the move. All right. And if move is not a valid moves, print this is not a valid move, else return move. All right. So how do we check it's not invalid moves? Let's see. We've already defined a list with valid moves, and what is that? Rock, paper, and scissors. And we're checking if this move is not listed in that, then we're printing this is not a valid move, else we're returning the move, which is what we were returning in our main function. All right. So if the conditional evaluates to true, then we're going to do something. If it doesn't, then we're going to do something else. This is called if statements, and this contains the logic of this basically makes up the logic of our programs. And now remember, we had strings and integers. So we're now going to talk about another variable called booleans. I'm pretty sure you all already know what are booleans. Very confident that you all know what are booleans. And yeah, let's move on. So booleans are supposed to be a primitive type of data type where you have only 0 and 1 which is returned or existed. 0, 1 in some languages, true and false in another. I'm pretty sure Python has true and false. So whether we get it returned true or false will be decided by our boolean variable. Alright, so our if statement is going to check if the move we entered contained within our list of valid moves. If it's not, it's going to tell you that you haven't made a valid move. Else it's going to return the move that has been validated as a valid move. All right. So great. Now you know if statements, you know booleans, and you know that these are used to evaluate your rules and hence give you the state of your game, right? So basically now we're just gonna use these to put together and make more of our game. All right. So we already have a basic rock paper scissors ready. Now we're going to be building our AI based opponent. All right. So what is the computer doing? Let's look into the computer code. All right. So a question for you all. I'm going to give you 1 minute to answer that. Before we look at how our computer decide what move to make, how would you decide? What makes you decide whether or not a computer? How would you decide what move to make? Basically, if you were playing rocks, papers, and scissors, how would you decide what move to make? Any answers? I am glad you brought this up. Exactly. When we played, it's very random, right? Especially rock, papers, and scissors. It's very intuitional. It's very whatever comes to your head. And oh, I just see a question here: list and array. So Yash, the basic difference between list and array is an array is supposed to be homogeneous when it comes to data type. A list can have multiple types of different data types. There are some more specific differences. You know what? Let me quickly drop a link for you to follow along. I like this, Rishabh. Sounds fair. Really, Yash, when you're playing some rock paper scissors with someone, do you really sit down and do conditioning in your head? I'm a very dumb rocks papers and scissors player. I mean, I just do what comes. Like if my hand, a lot of times I just end up doing a rock because I've been able to not decide what to do till the end. Thank you, Siddharth, for clarifying this. Alright, you know what, I was gonna drop you a link for that. So let me quickly. I know Geeks for Geeks have some good explanations. There we go. Copy link address. Alright, there you go, Yash. I think this might help you understand this better. Alright, so this was just to give you an idea of why maybe making AI come opponent here is going to be a tad bit challenging. Because it's so random, right, when you're playing. I mean, with chess, with tic-tac-toe, there's so much logic. With rock, paper, scissors, it has to be instantly. And if it's not instant, it's not fair, right? So, this is how the computer decides. You have a function called make move. You have something called a number, which is taking length of this state and giving the remainder out, dividing it by 3. Why 3? Because you have 3 states, right? You have rock, paper, and scissors. Okay, then you have a catchphrase. You will update the catchphrase data, but you're going to print the catchphrase, and then you're going to move the valid moves, and you're going to put the number here. Now, I'm going to give you 1 minute to understand what's happening here. All right, it's a little more complicated than the last piece of code. So, because it's a type inferred language, if you make a homogeneous list, it's basically an array. But again, the nuances might differ as per your application. And for example, a lot of times, right? A lot of times, if you are trying to print something in a bigger collab notebook, it's going to tell you that, hey, the list does not have so and so index. How is it deciding it's a list? It by default is going to go for a list before, until and unless you very specifically specify it's an array. All right, not a great game, Yash, I would say, if you end up doing this. All right, but yeah, you're right. Over here, this is random, and not random as much as we don't understand what this word state here is doing, right? I am not sure this is true, Abdul. I think you can specify an array in Python when you use the keyword, but we'll look into that in a bit. All right. So let's move ahead. All right. So where's the number coming from? We just use the state, right? The rest of it is pretty simple code. You're adding the length of state. You're getting the remainder out of 3. You are printing the catchphrase, and then you're passing the move by indexing a value out of the valid moves list. All right, and you're returning the move. But where did the state come from? All right, so our game state contains the list of moves the player has made so far. Interesting, right? That means we're keeping a tab on what the player is doing. We're trying to catch a pattern here, right? Our moves are stored in a list. This allow us to store multiple values at once. You can tell a variable contains a list by the square bracket surrounding the multiple values in it. Alright, so lists are a type of variable that can contain multiple values. Alright, alright, should we go on to finally the code? Alright, you're supposed to go in your glitch. Go on this app status, okay, on the left bottom corner, and click on terminal, and then do the same thing again. You all have already tried that, I know that, but go for it again, and let's see if you understand what's happening based on the code that we've just understood. Alright, so if this is still happening, that means you're right, and after this we'll start writing a bunch of code. And I'm waiting for you all to confirm whether or not you all are learning this. As soon as you do, we will move on. There might be, we'll have to look into it. Absolutely, you will. Let me repeat the steps that you need to do to get here. So, first, left bottom corner, you want to go into tools, you want to select terminal, then you want to type this out in your terminal. This will start the script, the Python script that you are using, and this is where you can start playing. Awesome, it's working for Aditya, and you will be waiting on you to try it out, and once you do, we will move on. Awesome, you guys got it too, which is great. So let's get going. Alright, so let's start by changing the catchphrase, right? We want it to be sound a little better. So let's update this. The singer, a Big Bang Theory reference is what we were missing here. And so you should just be able to edit the code, Rishabh. That shouldn't be a problem. If you've remixed the code, you can just start editing it. Interesting suggestion, Aditya. But then since you've used Python a lot, I'm not sure whether you're serious or you're just kidding around. So I'm not gonna take a chance here. So and approve the comment. So let's move on. So a little BBT reference here, Big Bang Theory had to come here at some point or the other. So we're going to be updating the catchphrase first. That way you know that you can edit the code. That way you know that the code works in the same way that we asked it to. What if we can add multiple catchphrases? How will you add multiple catchphrases without listing them all at once? We'll have to add some more logic, right? We'll have to add some more rules. And I see a new hacker in the chat. That's great. I'm sure you must be there. I just haven't seen you comment a lot. But yeah. Another nice catchphrase. So yeah, feel free to add your own catchphrases here. And let's see how we go around adding multiple catchphrases based on the logic. Alright. So currently our catchphrase is stored in one variable, right? And it can store a single value. How can we store multiple values in a single variable? All right, I don't understand the joke again, but let's look at what a list is, since you all already had a good discussion about what's a list. A list would probably be a good fit since they can contain multiple values. So we'll change our variable catchphrase into a list. Okay, so how do you change it into a list? By simply adding a multiple values to the same thing using a square bracket and comma and more quotes. All right, so let's give you a minute to add your favorite catchphrases here, and then we'll move on. Okay, once you add your catchphrases, you can't just print the entire catchphrase. You should try printing it though. In my opinion, you'll understand what will happen. You'll throw an error, right? See what the error reads and then add an index to it, right? You want to iterate through your list. So let's give you all a 1 minute here to update till this point where you're printing the catchphrase number and not just the catchphrase itself. Oh yeah, Anand, go ahead, use a random library, randomize your catchphrase selection. The logic might be a little different, but we'll figure that out later. Go for it. You know what? I agree that it's becoming too noisy. I might, if the fan's too noisy, let me know. I'll close it. I'll turn it off. Alright, if you all are still following along, you will. I hope you're on the same page. Let me know, and we'll move forward. Alright. And for some reason, my glitch won't load here, so I'm gonna try and load it onto my other system, which I always have it ready for backup since the Definity thing happened. And yeah, let's see if I can get it running here. Awesome, you will on the same page. Thank you, Rishabh. That's a tad bit comforting. I agree, Boone, and I think that would be better. It's just that remember we're live streaming, so this workshop is supposed to be easy for coaches to be take it, to really handle it online. That way, when once you already have the code, it's easier for me to just explain the code that's happening, right? So feel free to stick around. We usually have physical, not physical, but rather Zoom based workshops as well, where you can ask more questions. But yeah. Give me 1 second. Let me send me the glitch link because for some reason it's not working on this laptop of mine. But as soon as I do send it, it should be fairly easy. All right. All right. So let's move on before and let's go on to the next step so that you all can keep following up by the time I get my glitch work running. All right. So the slides. This I like this slide. So computers are dumb is what we're trying to prove here basically by writing this code. So they do exactly what you ask them to do. And they aren't going to understand if you make a typo, right? So if you put scissor, may a less S or forget nar, to it it's an invalid move. So how do you make sure that that does not happen? These are some basic things that makes sure that Python runs, right? All right, I like how you all are keeping the fan thing going in the chat. I'm getting a tad bit conscious now, though, so I might just turn it off in a couple of minutes if I have any more comments about it. Right? So these are some basic rules about Python, right? You need opening brackets, need to have closing brackets. You need to make sure that strings start and end inside a quote, double quotes, and your indentation has to be absolutely on, spot on for the Python to actually understand the logic. Because if the indentation isn't right, your code just won't work, right? So now we know that our code's working, which means your indentation, your basic syntax is correct, right? So let's see if your catchphrases work. Did you all try updating the code after making your catchphrases work? Let me know in case you haven't tried it or you're still trying it. I am watching the chat and I see. Awesome. So did you just change it or did you actually try it as well? Awesome. It's working for Yash as well, which is great. So, anyone else stuck anywhere? Okay, that's a fair thing for it to do, right? You haven't really specified how it's supposed to get the number, right? Have you changed anywhere? But did you add an index, Aditya? You were supposed to add an index to your code. Let's go back here and check. Did you add this, the index that you were the number? Always save it as a good practice. I'm sure it'll pick up all the changes even if you don't change it. But as a good practice, change the save the code before running it. There you go. So once you've added a list, make sure there's an index for it to iterate through, right? So let's get back here. Is there anyone else facing any other problem in running this code, this piece of code? All right, I'm waiting. I know it's working for Yash. He's already mentioned that. It's working for Rishabh as well. It's working for you will indeed. And Aditya is working on it. All right, so let's move a little bit forward and see how we can make it a tad bit more interesting. All right. So let's make our code a bit more smarter instead of making it so random, right? Instead of just looping through different moves, let's beat the opponent's last move. Now, again, I know we played very randomly, but I'm sure the computer can sense patterns. Thank you, Howdy, for confirming. Great. So let's see if we can make our code a little bit smarter. All right. So how do we make it smarter? We're going to edit this function. All right. We're going to basically edit the function that the computer is doing to make it faster. Wow. So we added now a list of catchphrases, right? How do we use the list now instead of just randomly printing a new catchphrase every time? Where we're going to add some more logic to it, right? We're going to add an entire chunk of if else statement to make sure that our computer is a tad bit more smarter than just randomly printing a catchphrase. All right, so we're going to first comment out the move variable that we used previously. All right, so we're not going to just randomly return one of the valid moves. All right, what we're going to do is we're going to add a variable that gets our last move from the state. All right, so we're going to basically keep a tab on what the last move was. All right, and then we're going to add an if statement which returns the move which would beat the player's last move. So let's say your last move was rock. If your last move was rock, what beats it? Paper. If your last move was paper, scissors beats it. And if your last move was paper, or my bad, what would beat rock? So if your last move was scissors, rock would beat it. And I'm not sure why is there an else move equal to rock, but yeah, let's see how that works, right? So Rishabh, is your Twitch not working, or are we talking about mine? Because I know mine isn't working. I'm waiting for it to open up in the other system. But yeah. All right. So let's move on. And if my grid starts working nothing like it, I'd be happy to share this with y'all. But until then, let's look at that. So now this will make our code a little more smarter, because what it's going to do is it's not going to make a random decision. It's going to make a decision based on the last move that the user made, right? Yeah, I figured it a tad bit later. Aditya. Thank you for the help, though. Yes, because we've already compared rock and paper as our moves, and okay, so good code would actually have an elif and not an else, and then there would be an else condition as well. But yeah, right now because we have only three conditions, it's okay to write it like that. Thank you. And yep, so this is going to make our code a little smarter. So moving on. You see this new piece of code that we've done, last move equal to state of -1. How do we access something with a -1? What is the -1 doing? Can anyone tell me? It's basically accessing the last value from where we are at that point. All right. So because we're iterating to the list, let's say you were on the fourth move and you're on the fourth index of the state, it will get the element from -1. Right? Exactly, the last element in the list. All right, so that's great because we're keeping on adding values dynamically to the list. We're going to get the last state, right? So great job, y'all. You already are pretty great with Python. So now once I've added this chunk of code, let me know if you need me to send this chunk of code in the chat. If you want to add, I'm happy to do that. And once you do that, y'all can try running the code again. All right. All right. Do you all want me to send the code, or I'll send it anyway. Alright, so getting started, is the yup for sending the code, or do you want me to? I'll send the code, yeah. I am sending it from the point where we're commenting the code so that it's easier for you all to just quickly paste it in instead of deciding what to delete and what to keep. There you go. Make sure you get the indentation right though. It's going to be a mess. It's going to be very messy if you don't get the indentation right. Also, while we're at it, I will also share the slides with you all because we're almost done. Alright, let me know once you have added this piece of code. Till then, I'll try and get my glitch up. Hopefully, this just might work. Huh, this one's working. Awesome. Alright, so let me share the screen as well so that we can keep switching between. There we go. That's my glitch. I'll be making all the edits from scratch here. So that's it. That's great. I'm gonna go back to the code that we're supposed to be adding so that you all have access to it. There you go. This is what the code we're changing. So I'm gonna quickly go ahead and change this code. Let me know once you're on the same page. And alright, Howdy's on the same page as well, which is great. Let's wait for another 3-4 minutes. So it's 12:40 in my clock here. Let's wait till say 12:43 for everyone else to catch up. Alright. Until then, what I will do is I will add the code myself, and if you all want me to show how I'm doing it, I'm happy to do that. Alright. Alright. So as multiple device problem. Alright. Is it still echoing? No, it's not. Perfect. So let's look into this and I really need to stop using multiple devices. Yes, I do have a mini event, last mini event Chrome Dino that we'll be playing, I think on Monday, IST wise, but I can check and get back to you in a bit. Yes. So here's the thing, right? Last LHD, when I ran the streams, I had some things growing up in every stream. The very first stream, my entire system hung up and I had to switch my system midway, which is why now, like, I'm pro at having another system ready just in case this one goes off. But yeah, I'm learning, especially juggling two devices is very difficult. So, all right. So, I think most of y'all are done. All of y'all who was following Aditya, I can't see him on the same page. Aditya, if y'all are following along, let me know. I'm happy to wait. And if not, we can move forward. We're almost done, folks. We're going to do another thing to make our code smarter, and then we'll be done. All right. So we've looked into indexes. We've looked into how it's working, but I'm not sure what you're talking about, Anand. The multiple device thing, the Chrome Dino, or this. I'm hoping you're talking about the code, but yeah, let's see. So, Anand, are you keeping up as well? Just FYI. I hope you are. Let's move on and let's make the code smarter and see how we can make it smarter. Even now, when we did make the changes in the catchphrase and made the changes in the extra logic, it's still very predictable, right? It's still very dumb. So how do we write code that will make random move half the time and then use the move that it used to beat the opponent the other half of the time, right? So writing this code would obviously be a little difficult. I'm sure all of you all can manage it. I have no doubt about it. But for the sake of time and for the sake of it, this being a virtual workshop, we're going to use Python's inbuilt functions to help us out here. All right. So let's get editing. All right. So these are the different changes you need to make. Before I start explaining, I'll put it in the chat so that if you all understand it faster, you all can just you know start adding it. So I'm going to add the entire chunk of code before copy already. There you go. So I'm adding it in the chat before I start. Good point, Aditya. I will be sharing the slides. I have them here ready to be shared, but I don't want you all to sneak off just yet because I want to make sure you all complete the workshop with me, and then I'll share the slides. Although if you have checked into the event, you should have already received the slides in your email. If you haven't, let me know. I'll share it anyway on the chat once we're done. But yeah. All right. So I've added the code in the chat, but what's happening now? Let's look at it. All right. So now what we're going to do is whether we're going to evaluate first whether what half we're doing. So we know we want to do something one half of the time and another thing the other half of the time, right? So what half are we at is what we want to evaluate first. We're going to use a random true and false for that. And what we're going to do is we want to add another statement, and we're going to figure out how that statement is going to make our code smarter. So if you're done adding the if random dot rand int 01 line, we can move on here. So let me know if you want me to wait. Thank you, Anand, for confirming that you have received it in the mail. If not, I'll share it anyway in the chat anyway. And if you the page that you used to check in and register, that also has something called resources. In that, you can also add the you can also find the slides, participant slides specially made for you. All right. So we're gonna figure out how to get a random item from a list using Python. So let's Google it because that's the best way to go about it, right? And this is the function we'll be using. Pretty simple, right? Considering how smart it's actually going to make our code. Pretty simple, right? So this is the code that we're going to be adding. As simple as this. Move is equal to random dot choices, and valid moves is our list of valid moves. Let me quickly add that for you in the chat as well so that you all can just pick it up and go forward. There you go. This is what you want to add into your last line here. This is going to make all the difference in terms of making it even a little bit more smarter. All right. Let's see what's happening. Can you all check if our code is running? I'm very behind on my machine. In case it doesn't work for you all, any one of you, I'll of course be doing the entire thing myself. But yeah, let's see if it works for all of you all. If it does, I might just be lazy today. But if not, I'm happy to make sure that it works on my machine and then send that code to you. As soon as you're done, let me know. You know what? While you're at it, I'm just gonna try doing it anyway in my PC. If it works, nothing like it. If it doesn't, we'll figure out a way to make sure it does. And I'm watching the chat. As soon as you all get done, let me know. Awesome! You will has added the code. You will Did you just add the code or did you try running it as well? Howdy's done as well. That's amazing. Let me see if I can quickly catch up to you all. All right, most of you all are done, and I'm really proud of you all. You all are great pace, man. I honestly wish we had had this space for Definity. We'll get back to it in the next workshop, though, I promise. All right, so great. If this is working for you all, we're almost done. So if this is how it worked, and if you could win or not win at least once, that means our code's working. And this is pretty random, right? I mean, our computer is, especially if you've played against AI, it's a lot more difficult to beat, right? It's not just based on the previous move. It's not just based on something this simple, right? So how does it work? It's too random, right? How is it working so well? Well, here's a little bit of probability lesson on you. A little probability lesson for you is conditional probability. Uh, if you flip a coin, 50% of the time it will land heads and 50% of the times it will land tails. Have you ever verified this? Have you tried to play it 4 times and seen if this actually works? But that's the math and that's how it's supposed to work. And we're using the same conditional probability math over here to kind of make our chances better, right? So our opponent already is pretty smart. However random it may seem, the code that we've added, our opponent is pretty smart. So let's go ahead and make it a tad bit more smarter, right? How do we do that? We write some code to keep a track of the previous move, so 50% of the time, and it will use the move that it beat the most often to use the other 50% of the time. Not today. You'll be making only this game today. This is the last chunk of code that you're going to be adding today. I promise. And but I know for a fact that after having done this, you're going to be pretty good at figuring out how to really write AI strategy. I mean, it's not that difficult. Is what we're trying to understand here, right? All right. So y'all can always make a great game. Thank you, Rishabh. I honestly appreciate the compliment, assuming I'm the one you're considering the mentor here. People are helping you out in chat as well, so I couldn't be too sure. All right. Great. So let's add this chunk of code now. Again, I'm going to put it in the chat. So we're going to be updating these two lines. Okay. So we're going to first check to see which move of the computer was beating the opponent the most, and not the last played move rather. Right. So first, what we were doing was 50% we were using the most beaten move, and 50% we were using the last move. This time we're gonna add the most commonly used move rather than the last played move. All right. So let me quickly drop the uh, slide code in the chat and get us ahead. So many tabs open. It's always such a hassle to find where the slide is. But yep, there we go. And I'm going to drop the entire chunk of code for this one, the entire if else, and you all can just pick up the line you all need. All right. There you go. And yeah, after this, it's going to be a very simple right from here on. But this is the last piece of code that we're adding. So great, you guys. You're done. So the whole point of this is to understand how AI really works. There's not always not always is the keyword. A lot of times there's some beautiful algorithms at the back that are running, but for this case, something as simple as game programming, as simple as programming is this game, you can have some more math based algorithm like we're using to here, like random and the 50% conditional probability. Did it split up the comment? It did on YouTube. I didn't know there was a minimum character limit on YouTube. I just found that out. Great. All right, let's move on. Shall we move on? Or do you all want to wait here for a bit? Awesome. So now what we're going to do is we're going to go to our most common function and we'll see that sure, you will. So let me quickly explain what this code is doing again very quickly. So what we're going to do is we're going to go to our most common function, right? Before this, what we were doing is we were using 50% of the time, the most beaten, 50% of the time, the last move, and 50% of the time, a random move, right? So first we were using a random move, right? We were just ekdam in the initial code, right? What we were doing was we were using a random move. The second time we updated it to use the last move, right? Then what we did was we using the conditional probability, base, we decided 50% of the time we'll use the last move, 50% of the time we'll use the random move. Now what we're doing is 50% of the time we're using the last played move and 50% of the time we're using the most common or the most used move. Does that make sense? I hope that made sense. I don't know what the plus was for, but I hope that made sense. So now what we're doing is we're going to our function and we're trying to add code that helps us make the most common move first 50% of the times, and the next 50% of the times it's gonna play a random move. All right, so let's go on and update the loops in the make common function as well. Right, we've done this, now we're doing this. All right, we're gonna, okay, this is not the right function, here we go. All right, so now for move in list we're gonna go on line number 27 in case you can't find it the first time. It should start around line number 27, and yeah, this is another loop. This, you're not supposed to make any changes here, you just need to understand what's a for loop in case you all don't know. That's great, Yash. All right, then we have our conditional statements. So we're going to compare our count of which one was beating it the most times and use that, and whichever is the greatest we're going to use that. So whichever conditional returns true, also known as whichever move the player loves the most, is the move our computers are going to counter at least 50% of the times. All right, so nothing for you all to add, just a simple understanding of what's really happening. And let's see if our code works again. Is anyone still following along? If you all are, let's see if you all can get the code to run and see what happens. I'm waiting in the chat to see where you all are at. This is the last piece of code that we were adding. And yep, we're almost done. Just a couple of more steps as to awesome, awesome. You all are total rock stars when it comes to following along this code, which is amazing. I've never had such a smooth workshop. There's always, I end up having more errors almost every time because I'm always switching between systems, and this is great. I'm so glad you all are able to make it work. So, all right. Whom all are we waiting on still? So Anand's working, Aditya, you will are all on the same page. Howdy hasn't updated there. Howdy updated it. Great. Yash, we're waiting on you. Rishav, great job. Who else was following along? Boone, are you still following along? I know you're not very fond of this workshop the way it is, but let me know if you're still following along. Is that a question? I know. I hope it wasn't that hard. Oh, Yash has been done already. Right, Yash, you updated me. My bad indeed. All right, great job, y'all. We're through. I promise you, we're through right now. And there's just some more steps and pondering for you all to do. So let's look at the slides again and see what the slides would probably want us to keep in mind. So what the computer is doing right now is it's calculating the conditional probability of you making a move and is using to decide which move it should make to beat you. So you just coded a really basic AI. Alright. So like I said, not all AI has to be very complicated and has to have a huge algorithm. This is a very simple way to, look at AI. Alright. So we learned a lot together, especially if you're new to Python and you didn't understand the syntax before. You have learned so much. You give yourself a pat on the back for getting through this in such a short time. I mean, we're like 30 minutes ahead of our time, and I'm so glad. I mean, I'm never on time. My workshops always run over. They never complete on time. So I'm so proud of you all that you all have been able to manage this. And let's see. Now it's your turn to write the rules. So we wrote a lot of code together. We changed a chunk of code, and you understood how to slowly change, right? You start with the most basic version, add a little bit of complicated code, and keep complicating it till you understand what's happening, and then debug it, because at some point you'll have to debug it, right? Now what you can do is adjust how frequently the computer plays a random move. Try right now we're doing 50%. Try different percentages. Look a little bit more into how you can play around with probability. Okay, play around with what, it does not have to be 50%, 50%. You can have another case. We did the first case of the last move. You can divide it into 33% of the times. See how you want to go about it, and yeah, make sure that your computer is the evil one in this case, right? And you're the one making it evil, so it's all good for the most part, right? So we're done, all, and I'm so glad you all stuck around till the end. You all have been super interactive. I think this is one of my favorite workshops that I've ever had. Yes, be unlike Google in this. All right. All right. So review and quiz. You just built your AI, like you built. I know Aditya is into AI and ML, so I don't think it might have been a big deal to him, but great job if this is the first time you built AI. You've learned the basics of how to make a game. Now you know that it's not supposed to be very difficult. It's not supposed to be too complicated. You can just take this code and build a similar game and then keep changing it to the point where it becomes your game. You also learned a lot of Python, especially like I mentioned. If you haven't done Python before, completing this is a pretty huge deal. Okay, make sure you're like super proud. And yeah, you've learned how to search answers online, but you're a pro hacker, so I'm pretty sure you're already great at that. All right, so now, folks, I am honestly not sure if you're supposed to complete this because this is a GHW workshop. But if you all can open this link and see if there's a quiz available for GHW, I urge you all to take it. Let's see if I can open this actually link, and we can solve it together. Let's see if we can solve it together. Python. If it opens, and well, it's mostly feedback, and we like feedback. We like making workshops that are more towards your liking and how you want it to be. Exactly, Yash. That's a very good observation. So that's what I call product thinking. You want to make sure that the player is not frustrated in the end either. So yeah, that's a great point, and it's good to keep in mind when you're trying to be evil. How evil is good for you. Okay. Let me see if the quiz has Shabdo. All right, folks. So I'm going to share my screen with the quiz and let's solve it together. You're going to want to enter these details in the form that it's asking. It's mostly going to be a survey after this point. So what you want to do is you want to select basic training, Python. I'll drop the link quickly here if you want. And you want to, for the school and organization, don't put MLH, put Major League Hacking. It's kind of the norm here. And yeah, the email address can be your email address, whatever you use to sign up. These are the three basic pieces of information you want to put. All right, so let's start with a couple of questions. And now it's going to ask you for a little bit of survey. Oh, there's no quiz. So it's just survey. That's sad. Yeah, you all can just complete the survey. There used to be a quiz. I think they're kind of revamping the entire thing, so there might be no quiz for the time being. But yeah, the quizzes used to be fun. If you all want, we can have a quiz later. So, folks, we're done. We're done for the day. This is my third stream today, and I am, you know, sufficiently tired and really, really happy of the way it turned out. I'm so glad all you hackers turned up today. It's a Saturday. You all are working so hard on a Saturday. I'm so proud of you all. So I'm gonna go. Also, I turned off the fans. I'm feeling really hot right now, and I really want to go turn the fan back on. So I'm gonna close the session. I usually have people tune in, join the streams in the end of the session and just talk how it felt. But because I have two more streams left, I'll do that in those. So we have one stream tomorrow morning, which is my third part of embedded systems part. This track that I created. It's my content, so I really appreciate some honest feedback. So if you all can tune in, listen to me blabber for an hour, and tell me that hey, you know what, this is useless, or you can make this better. I'm happy to get either of the feedback. And there's Monday Chrome Dino that I'll be doing the mini event. But tomorrow I'll be really happy. Even if it's not your domain, just tune in, tell me how it's going. I would really appreciate that. All right. Thank you so much, folks. You all can reach out to me on Discord and Twitter. That's my handle. And I'm so glad you all tuned in today. Oh, the form is followed by a quiz. Great. Thank you so much, Yash, for confirming. So there is a quiz in the end. Do take it. I would love for you all to get 100%. I know for a fact that you all were following along, so I know you'll get 100%. Thank you, You Will. You Will has, I think, worked harder than me. He's tuned into every session and he even did the stacking of the books while we were at it. So, thank you so much, all of you all. And I'm going to close the stream now. Bye bye.